All right, so let's take a look at today's lesson. Today we're going to look at both general and particular solutions to differential equations. Okay, we're going to look at both of those. First, let's get through some vocabulary word and some concepts, and then we'll practice. So separable equations, that's like a vocabulary word. What are separable equations? That means that they're the kind of differential equation that can be solved explicitly. In other words, we can solve them. Separable means that we can split. So what we do is we split. So here's our differential equation right here. Notice that I've got a dy and I've got a function with y's in it. And then I have a dx and I have a function with x's in it. And so what I would do is I would separate that, and we're going to practice that today. We're going to separate the differential equation. This is the steps that we would use. And we're just going to go through the steps and then we'll practice the steps. Okay, so the first thing that we would do is we would rewrite the differential equation by moving all of the y's and the dy, and we move all the x's and the dx to each, they're on their own side. Okay, they each get a side. Now, please note that these little things right here, these are called differentials. These two things right here, the dy and the dx, are called differentials. And the differentials can only be whole, like in the top. They cannot be in the denominator. So let's make ourselves a note. These are called differentials. And they must be in the numerator. Or whole. They're not allowed to be in the denominator. Okay, so that's a really big deal. So for us, if we're solving a dy dx, we pretty much kind of stuck with moving the dx to the other side, to the right side, because it's in the bottom. We can't be in the bottom, so we pretty much need to move it to the right. So typically we'll move all the y, the dy to the left, and all the x and the dx to the right. That's just the way that it's set up for us. That makes most sense. I'm going to pause there for a second. Is everybody okay? So the differentials have to be in the numerator or like a whole. They can't be in the denominator. All right, so we would, step one, we rewrite. So we have the y and the dy on one side and the x and the dx on the other. Then what we do is we will integrate both sides of the equation. I'm going to put a note here. We use 1 plus c, and we put it on the right. Now, do you have to do what I'm saying? No. I'm just telling you that is the easiest thing to do. When we integrate both sides, we just use 1 plus c, and we put it on the right side, like with the x's. It just makes our life easier. And lastly, they do require us, if we can, which we can most of the time, they require us to solve for y. So typically one of these, like solving the differential equation, would be on the AP test, it'd be like worth 4 or 5 points, where one, the very last point, would be solving for y. So, and that's the algebraic part that we know and love so very much, the algebra. Woo! Okay, so that's the process that we're going to be practicing on today. Are there any questions on the general idea? Okay, so we're going to work on general solutions first. And again, I want to talk about the vocabulary word. What does a general solution mean? What does that mean? A general solution means it will have a plus c. That's a general solution. It will have a c in it. What is a particular solution? Okay, a particular solution means that we solve for c. We actually know what we'll figure out what c is, what exact number it is. That's all. A general solution means we're going to have a c in it, and a particular solution means we're going to find out what c is. Otherwise, the process is exactly the same. Okay, are we okay on that vocabulary? General solution versus particular solution? Okay. So one other thing I want to mention, and I've mentioned this many, many times in, I teach BC also, as y'all know, many, many times, and somehow we can forget. I just want you to understand what is a solution to a differential equation. And I'm going to write where this is so important. I'm going to write it out here. What is a solution to a differential equation? Because they're going to ask you to find the solution all the time. What is it? It is the position. Okay, it's the position. That's what it is. So you're typically going to be given the first derivative, and you're going to find the position. Okay, that is when they ask you to solve the differential equation, they're asking you to find the position. And I think we've talked about it in here as well. So when we're solving it, we're finding the position. Again, vocabulary words. If it asks you to solve and you don't understand what that means, then you're not going to know what to do, right? It's certainly possible for us to solve them, but if you don't know what the word means, then you don't know what to do. So vocabulary is really important. So let's look at our very first one. The very first one, we're asked to find the general solution, and we know that means that we're going to be left with a plus c, right? That's what that means. We're going to be left with a plus c. So what are we going to do? We're going to take this and we're going to separate it first. Okay, we're going to separate it. So I'm going to leave the dy where it is, and it's kind of like cross multiplying if you want to think about it that way, if maybe that makes more sense to you. Typically, with some of the more straightforward ones like this one, we can just cross multiply. So this was going to be y dy equals x squared dx. Okay, so that's step one, is separate. So we've got the y and the dy on the left and the x and the dx on the right. Now we're going to integrate both sides. And here's where our practice in antiderivatives is going to be helpful. So we're going to have to do the antiderivative of y, which we do the reversal power rule, right? So this is going to be 1/2 y squared equals. Notice I did not put a plus c on this left side. Reason being, I'm going to put it on the right side. We just have one equation, really, that we're solving. We don't need two plus c's. We just need one of them, and we're going to put it on the right because that's to our advantage. And so I do the reversal power rule on the x squared, and I get 1/3 x cubed, and then I got plus c. Now, if we had the information to find c, we would do it immediately. Because I'm going to show you what happens when you don't do it immediately. It just gets kind of muddied up. Now we don't know what it is, so that's not going to be our role, but if that is the solution, but I'm supposed to solve for y. So what would I do? I would have to multiply both sides by 2, right, to get rid of the 1/2. So that would give me y squared equals, let's see, 2 times 1/3 is 2/3 x cubed, and we don't do 2c. We just don't. Typically what we do, if we do anything algebraic that changes the value of c, what we normally do is we just change the letter to a k. I know that's very troubling. I don't like it either. And we don't do a whole lot of general solutions. We mostly do particular solutions, but I just want you to understand that why did I change this to a k? Because 2 times c is just kind of weird. I mean, it's just a c, right? And so the k tells us that we have done something to it. We've done something to the c. It's not just a regular old c anymore. There's been some kind of a adjustment done to it. Okay, I just want to make sure we're okay. So we don't run around saying that's 2c or a 1/2 c or 3/4 c, nothing like that. We just change the variable. And the normal variable to change it to would be a k. Now we want to take the square root of both sides. So we get y equals plus or minus the square root of 2/3 x cubed plus k. And that's our general solution. Okay, so I'm going to make a note here for ourselves. This is just a note for the K. So if we multiply, divide, to the C, we change the variable to a K, and that's just the typical thing we would do. That would be the standard thing to do, is if we're going to multiply C or divide C by some number, then we just change the variable to a K. That just shows that, yeah, that's not the original C that we put in. It's been messed with. Okay, how are we doing? Okay. So we have another page of general solutions, and then we've got a page of particular solutions. So we're just going to practice. We're just going to practice the different kinds of things we might see. So we're asked to find the general solution again. I'm going to do my first step, which is to separate. So I've got dy over y squared equals sine x dx. Okay, I've separated. Now I'm going to integrate both sides. So I have a word of caution here. I've seen it so many different times. The antiderivative of 1 over y squared is not ln. The antiderivative of 1 over square root of y is not ln. What is the only antiderivative? What would I need to get an ln? Just a 1 over y, right? A 1 over y or a 1 over x, that gives me an ln. Nothing else does. All the rest are reversal power rules. All the rest of them. So I'm going to just put this up here. This is just some, scratch work. So this is just some scratch work so I can think. So I basically have y to the negative 2, right? I'm just going to do my antiderivative over here just to kind of think through my antiderivative. So I would add 1 to the negative 2. See, negative 2 plus 1 gives me a negative 1. And then I would divide by negative 1, which is the same thing as multiplying by negative 1. So that is my antiderivative. This right here is my antiderivative, and I'm just scratch work. So we could do this in our head. We don't have to write it out, but I wanted to make sure we understand what's going on. So I'm doing the reversal power rule, and this becomes negative 1 over y, because y to the negative 1 is, negative 1 over y. And that's the left side. That's the antiderivative for the left side. Are we okay with that? Okay, so the right side, I need to think. The trig, it's kind of tricky. So what would I have taken the derivative of to have gotten a positive sign? I would have taken the derivative of a negative cosine. That's what I would have taken the derivative of. And then I got my plus c. Okay, if we had information on c, we would find it right now. But we don't. So we're required to solve. All right, so what I'm going to do is I'm going to multiply both sides by y just to get it off the bottom. Okay, just to get off the bottom. We need to solve for y anyway. Okay, now when I solve for y, I'm just going to divide both sides by that negative cosine x plus c. So y is going to be the negative 1 over negative cosine x plus c, and I'm done. So I solved for y. So that's another example of a separable differential equation. We okay? Okay. Next one, and that's a general solution, right? General solution. We've got a c in it. Notice that I didn't really multiply c by anything, like a 2 or something, so I just left it as a c. And that's perfectly fine. Okay, the next one, again, we're going to find the general solution. So we've got to separate it first. So I need the dy and the y on one side and the x and the dx on the other. Okay. Integrate both sides. Now we've got the 1 over y, right? The antiderivative of 1 over y is ln absolute value y. That's what it is, right? The antiderivative of 1 over y is ln absolute value y. There's our ln. See, and I can understand why students get confused. See how close these are? They're so close to each other. We just have to remember, that ln only pops up when this is to the first power. This has to be to the first power for ln to pop up, right? If it's to any other power, it will not work. Okay. So then on the right side, I'm going to do the antiderivative of x. And what do we get? We get 1/2 x squared plus c. Okay. So, oh, algebra. We love algebra. Okay, I love algebra. We need to solve for y. Look, it's trapped inside there, right? It's trapped in with the logarithm. Do we remember what we do to release it from there? Do you remember the circly things? Remember those? This is a circly thing, right? The base of the ln is e, right? So I would do e to this side equals that. Remember that circly thing from pre-cal? That's what we're going to do. We're going to basically change it up, right? We're going to convert it because we have to solve for y. All right, so let's do that. So we've got e to the 1/2 x squared plus c equals y. Now, it's actually absolute value y, but I want to talk to you about this for a second and show you why we don't need absolute value anymore. So, are we familiar with e, right? Let's look at the graph of e, right? E goes like this. Is e ever negative? Remember, it's not, right? There's a horizontal asymptote here, which is a terrible drawing, sorry. It never goes negative. So do we really need those absolute values there? No, we do not. So we don't put them, okay? We don't put them. And this is my answer. I hope you can see that if we didn't solve for c right here, this would be a pain to work with, don't you think? We really need to get into our heads as soon as we put a c, we would solve for it if we're doing a particular solution. Okay. How are we doing? One more. So this looks, at first, looks kind of impossible. It's like, wait, what a minute. I need to separate the x's and the y's. And look, there's a xy thing there. What might I do? And I can't add the negative 4x to the other side. You can't add to a differential. That's really important. There is no adding or subtracting to a differential. Remember what the differentials are? Remember that vocab word? The dy and the dx? There's no adding or subtracting to that. You can only multiply to them. You know, I mean, or divide to them, I suppose. So what in the world? How are we going to fix this? Any ideas? Yes, very nice. We're going to factor. We're going to factor out, in this case, we've got a 2 and an x we can factor out. So let's do that. Because really, that's our only option. We're not allowed to like add and subtract stuff to the other side. That's not a thing. So let's see. Let's make sure I did. So we've got 2x. Yep, that looks right. Okay, now we are able to move the x's and the y's separate from each other. Okay, so the 2x is going to stay there. So I've got dy over y plus 2 equals 2x dx. Okay, so let's work on the left side. The right side's pretty easy. Any ideas on what we would do on the left side? That really is a U sub. I would call it a baby U sub. So I'm going to do some scratch work out to the side. You might be able to do this in your head and not have to do any scratch work. If I could spell scratch work. Okay, so it would be U would be Y plus 2. du would be dy. So basically we're integrating. We'd be integrating 1 over u du. That's what we would be doing. Right? This is, you can think this in your head or you can write it out on the side or, you can change the way it looks, however works for you. All right, so when I integrate 1 over u, what do I get? ln u, right? I get ln u. I get ln, and we know what u is already, right? It's y plus 2. And that's what we get. I do the reversal power rule for 2x, and I get what? That would be x squared divided by 2 plus c, which, the 2's go away. So I basically get x squared plus c. Okay? Now our job is to solve for y, because that's our last step, step 3. So step 1, we'll just write it out. This is step 1, right? We separated it. Step 2, we integrated it. And step 3, what did we do on step 3? Solve for y, right? We solve for y. Now this is an ln. So what am I going to do? I'm going to do the circly thing, right? So I've got e to the x squared plus c equals y plus 2. Okay, I'm close. I've almost solved for y. I'm very close. So I just need to finish up. So y is going to be negative 2 plus e to the x squared plus c. And that's all the ones we're going to work with general solutions. Okay? Questions? All right, so let's work on particular solutions. Okay, the last 3 we're doing are particular solutions. And how do I know? It doesn't say particular. How do I know it's particular? Because it gives me this, an initial condition. That's how I know it's particular. It wants me to find C. Okay, it wants me to find C. It doesn't say particular, but it gives me the initial condition, so I am required to find C. All right, so the first thing that I would want to do is I would want to change this to be x squared y squared. And I'm just going to write a note up here. I'm not going to actually rewrite it. This is just x squared y squared. Okay, otherwise we're not going to be able to separate it. So let's separate it. So we've got dy, will that be over y squared equals x squared dx. Step 1, separate. Step 2, integrate. So on the left side, that's the reversal power rule, which we have already done up above. If you recall, that antiderivative turned out to be negative 1 over y. Okay. The antiderivative of x squared, we do the reversal power rule. We get 1/3 x cubed plus c. Now, we stop right now. We stop and we find c. I highly recommend for you to stop and find c. Okay, so let's do that. So let's move that over here. So I've got negative 1 over, let's see, y is 1. Equals 1/3 times 1 cubed plus c. Okay. So I've got negative 1 equals 1/3 plus c. So what is c? C is going to be what? Negative 1 minus 1/3? That's what, negative 4/3. Okay, that's what c is. Can y'all see that okay? Okay. All right, so now let's put the c back in. Before we do anything else, we're going to put the c back in. So we've got negative 1 over y equals 1/3 x cubed minus 4/3. Now, there's several ways that I can solve for y. I could do what I did previously and multiply both sides by y, but it would give me a complex fraction. And we really don't want to have a complex fraction. So there's another, not that well-known algebra technique. And I'm going to talk about I'm going to do a little aside, and I want to talk about the algebra technique for just a moment. And you'll probably already know this, so just humor me. So we have an algebra technique that says, if I have one fraction equal to one fraction, let's do this for example. I have 1/2 equals 1/2. Do y'all agree with me? That's true, right? I am allowed to take the reciprocal of both sides, and that will also be true. So would you agree with me that 2/1 also equals 2/1? Right? That's true. Okay, so that's the technique that we are going to use. But here's the trick. It can only be one fraction on each side. One fraction, because this is where students make mistakes on this algebra. I cannot have one fraction equal to two fractions and do the same thing. Okay, you with me? So, what do I want to do? I want to turn this side right here into one fraction. Now, it already has a common denominator. It's really not going to be that hard, right? So let's do that. So I have -1/y equals x cubed minus 4/3. Okay, and now I'm going to pause for just a moment and make sure we're okay. Does everybody understand? So I have one fraction equal to one fraction. Now I'm going to flip them both upside down. So this turns into -y/1, and this turns into 3/x cubed minus 4. And that is perfectly legitimate. My last thing would be to multiply both sides by -1, right? I need y by itself. So I'm going to have y equals -3/x cubed minus 4. Now I have something that's not a big mess, like that. If I had done it by multiplying both sides by y, I would have a complex fraction, then I'd have to try to fix it. That sounds just like way more trouble, way more difficult than doing this. So I'm going to pause. Are we okay? That's some fancy algebra now, right there. Okay. So we have a couple more. Hopefully you're going to getting a kind of a good feel for these. We've done several types, so that hopefully that will, carry over into the other ones that you will see. So number 6 says find the solution. So we know what that word means, right? Find the solution. What does that mean? It means find the position, right? That's what it means. Solve a differential equation means find the position. So here we go. So let's separate. So I have y dy equals 2x dx. Okay. So we're going to do our antiderivatives, just reversal power rule. So it's what, 1/2 y squared equals, let's see, the antiderivative of 2x is what, x squared plus c. I have a c. I stop right now. I stop and I find c. I'm going to put it out to the side. We're going to stop and find c. So let's see. I've got 1/2 1 squared equals 2 squared plus c. So what is that? 1/2 equals 4 plus c. So c is, what would that be? -4 plus 1/2 would be -7/2. Okay. So let's put that back in. So I have 1/2 y squared. In fact, you don't have to write this out, the finding c. If you want to do it in your head, you certainly could. I personally can't do it in my head. I have to write it out. But if you can do it in your head, that's fine. You don't have to show that work. So I've got equals x squared minus 7/2. Now, why am I using fractions instead of decimals? Really, because it simplifies much nicer. Because when I multiply through by 2 to get rid of that 1/2, what's going to happen to the negative 7/2? It's going to turn into just a negative 7, right? That's going to be so much nicer. So I recommend dealing with fractions. Because, you know, we need to solve for y, so multiply through by 2. So I get y squared equals 2x squared minus 7. Square root both sides. And I get y equals plus or minus the square root of 2x squared minus 7. Now, here's where it gets tricky. I want to just talk about this for just a moment. Here's where it gets tricky. I really have two solutions there, don't I? I have the positive radical and the negative radical. Y'all see that? I have two. I am only allowed to give the particular one solution. I cannot give two. So how do I know? How do I know which is the right one? What I have to do is I have to go back up here and look at this. So if I were to plug a, let's just say if I were to plug a 2 in here, so let's do that. So let's plus, so we have what, 2 times 2 squared minus 7. What is that? So that's what, 4 times 2 is 8. 8 minus 7, so that's square root of 1. Square root of 1 gives me 1. Which one of those solutions did I use? Did I use the positive radical or the negative radical? I used the positive one. Therefore, I have to change this and say that my solution is the positive radical, which is 2x squared minus 7. I am not allowed to show both the positive and the negative. And really, this scenario typically only comes up with this kind of problem where you have y squared equals. So please, that's just the norm. You have to pick. And how do you know what to pick? You know what to pick by what this says, what your initial condition is. That's how you know what to pick. Okay, I want to pause there for a second. Are we okay? Okay, so we know how to pick the proper one. It has to do with the initial condition. Always. I'll put a little star up here. This is all about the initial condition. Okay. And actually, we'll put a note here just so that we're aware. So note, just in case we forget, note, can only use solution that goes with initial condition given. Initial condition given. Period. Okay, so that's kind of a big deal. You can only use the solution that matches the initial condition that we're given. Okay? All right, one more. We're almost there. Okay. Let's see. Find the solution to the differential equation. Okay, I need to move this note down. Here, get it kind of out of the way. Okay, so that's a note right there. There we go. Find the solution to the differential equation. Okay, they gave it to us with initial condition. We're just looking at varying, same scenario every time. It's just different functions we're dealing with. So let's separate it first. So dy over y plus 2 equals e to the x dx. Okay. We actually did one very close to this, didn't we? Remember the little baby u sub? Why do I call it a little baby u sub? Because it would only involve a constant. It's pretty straightforward. So what is going to be the antiderivative of this part? Can we do that in our head? Yes? ln of y plus 2. Okay, that's little baby u sub. Equals, oh, I love e to the x. What's the antiderivative of e to the x? E to the x. Isn't that the best thing ever? e to the x plus c. Okay, we're going to stop. We're going to find our initial condition. I'm going to move over here to the side. So I've got...
Plus c go in the x, like next to the x, or like in the exponent?
It's next to the, it's not in the exponent. It's not. That's a good question. It's not. It's just out to the side. Okay, if we converted right now, it would be in the exponent, and that would be a really big problem on finding c, wouldn't it? I mean, I wouldn't like that. I mean, yes, you can do it, but I wouldn't like it. So we're going to find c right now before we convert and turn it into the exponent. Okay, so let's do that. So we've got ln of, let's see, y is 0 plus 2 equals e to the negative 1 plus c. I have it reversed, don't I? Yep, I have it reversed. So the x, let's see, is the minus 1. This is the x. Wait, so goofy. This is the x and this is the y. Okay, so the y is this one. So I've got negative 1 plus 2, and then it's e to the 0. Okay. So that is ln of 1 equals, do we know what e to the 0 is? It's 1. Do we know what ln 1 is? It's 0. We have to know what ln 1 is. What two ln's do we need to know? ln 1 is 0, and what's the other one? Do you remember? ln e is 1. So we had to know those two. Those are like memory things. We have to know because we're expected to know. So 0 would be 1 plus c, so c is negative 1. Okay, are we okay with that? All right, so let's plug that back in. So I have ln absolute value y plus 2 equals e to the x minus 1. All right, now we do our little conversion thing, right? Our little circly thing. So I've got e to the x minus 1 equals y plus 2. Okay. Now, I mean, I could put the absolute values here, but do I need them? Can e to anything ever be negative? No, never. Even if it's e to a negative number, it still can't be negative, right? There can't be negative, so I don't need those. All right, so now I move the 2 over, and I get y equals negative 2 plus e to the x minus 1, which is kind of weird, but that's the way it goes. How are we doing?